everyone to TQM Quest. Today, we're diving into the world of quality function deployment. In this game, two teams will battle it out over 3 rounds of challenging questions to see who knows best how to make quality the main priority. By the end, one team will be crowned take home the title of TQM champions. Now, let's meet our today's week team representative. Let's meet our teams. First up, we have Mr. Renzo as representative of Team A. This team is all about teamwork and innovation. Let's welcome Ms. Morada of Team B. Welcome to round 1, the voice of the customer. In this round, we're diving into what QFD is, its origins, and why it's so valuable to businesses. Each correct answer will be followed by an explanation that connects this concept to real-world applications. Let's start with Team A. Team A, here's your first question. What is Quality Function Deployment, or QFD?
QFD is a process that defines customer requirements and turns them into engineering plans for the product.
Great answer! Quality Function Deployment, or QFD, is like a bridge that connects what customers truly want to the technical specifications. Engineers will follow to create the product. The process starts with identifying what features or qualities are important to customers. This is called the voice of the customer, or VOC. QFD then turns these customer needs into measurable goals that engineers and designers can build toward. This means every part of the product development process is guided by what the customer values, which increases the chance of a successful customer-focused product.
Team B, your turn. Here's your question. Who developed QFD and where did it first emerge?
QFD was first developed in Japan by Yoji Akao in 1960s.
Team A, here's your next question. Why should a company implement quality function deployment?
Quality function development, or QFD, helps the company understand and meet the customer needs effectively.
Team B, here's one for you. What is one way that QFD is customer-focused?
It takes the customer want and translate them into technical design specs so the product align with their expectations.
Great answer. So QFD emphasizes the voice of the customer by breaking down their needs into specific, measurable targets. So this ensures that the focus stays on what the customer values from design all the way to production. So by doing this, QFD ensures that the final product reflects on what the customer actually wants rather than the assumption. So this customer first approach makes sure that each stage of development remains aligned with the customer expectation.
And that's the end of round 1. Team B leads with a solid score after that round. Let's keep up the energy as we head into round 2, House of Quality. Alright, Team A, let's start off round 2 strong. First question, what are the 4 phases in the QFD process?
The 4 phases of QFD process is the product development, product process development, and process quality control.
Great answer. So the 4 phases of QFD are designed to guide the entire product development process. So it starts with defining the product based on the customer needs, the product definition. Then moves to the design and specification of the product, which is the product development. After that, we focus on designing the process to make the product, and that is process development. And finally, we ensure that the manufacturing process is under control and meets all the requirements, which is the process quality control.
Now for Team B, in Level 1 QFD, what are the main sections of the House of Quality and can you explain them?
The main section are the what, how, body, root, competitors, comparison, relatives, importance, and lower level or foundation.
Excellent. Let's break down this section using a practical example of designing a mounted bike handlebar step. This will give you a clearer understanding of how the House of Quality works. What are the customer requirements? What they want from the product? For our bike step, this include aesthetic, like reasonable cost, aerodynamic look, nice finish, and performance. House are the design requirements needed to meet the WATs. In our case, material selection, steel, aluminum, titanium, and manufacturing processes, die casting, sand casting, forging, are the house. Next, we have the body or main rule. The body shows how the WATs and house relate. We wrap this relationship using a system of symbols where we assign values like 0, 1, 3, or 9 to indicate how strong the connection is. Then we came to the roof. The roof show how the house, the design requirements interact with each other. This matrix helps us understand potential conflict or synergies. For example, if we look at the interaction between titanium and sand casting, it's a strong negative correlation because titanium can be sand cast. So we would rate that as -9. On the other hand, aluminum and die casting have a strong positive correlation since aluminum is often used with die casting. So we would rate that as +9. The rule ensures that design future and processes we choose can work well together. Now, let's talk about competitor comparison. This section allows us to compare how well our product is likely to meet customer needs against our competitors. We usually rate a scale from 1 to 5, with 5 being the highest level of customer satisfaction. So for the lightweight requirements, our handlebar stem might rate a 4 because it is light, which is good, and this might be on one part with competitor A, but better than competitor B, who might only rate a 3. This comparison helps us see where we stand in the market and where we can improve. After that, we have relative importance, which is all about prioritizing which design requirements are the most important. We calculate this by multiplying each customer requirement's importance factor with its correlation to the technical requirements. Finally, we have the lower level or foundation. This is where we set specific target values for each technical specification, ensuring the design stays aligned with customer expectation. After going through all the previous section, we now have specific goals to hit. For instance, if lightweight is a priority, we might set a target of using aluminum as the material and die casting as the manufacturing process to meet the requirements. The lower level guides the rest of the development stages, making sure that everything aligns with what the customer really wants.
Team A, how many levels are there in level 2 QFD?
There are 2 levels, which is system and component level.
That's not quite right. Team B, can you steal the point?
There are 3 levels: system, subsystem, and component.
Good answer. So in level 2 QFD, we break the design down into 3 levels. First is the system level. Looks at the overall product design and how different system impact is. Second is the subsystem level. It focuses on individual subsystem and how they support the system. Lastly is the component level. Identifies the specific components and features that need to be optimized. This level helps us zoom in on what's the most important at each stage of development.
This is the final question of round 3, the benefits of quality function deployment. I'll ask the question and you'll have 3 seconds to answer. The first team to answer correctly wins. Ready? What is the main benefit of implementing quality function deployment QFD in an organization design processes?
It helps to ensure customer needs are accurately translated into product design, improving customer satisfaction.
Absolutely. The main benefit of QFD is that it helps our organization take the voice of the customer and translate it to specific design and technical requirements. By integrating customer needs into design processes, QFD minimizes the gap between what customer want and what the product delivers. This systematic approach ensures that products are designed to meet or exceed customer expectation, ultimately leading to improved customer satisfaction and loyalty.
And that's a wrap for today's TQM Quest. Congratulations to Team B for being our TQM champions this week. And well done to Team A as well for a strong performance. We've learned how crucial quality functions